Hi ladies, Mr. O'Sullivan. Today we're going to look at lesson 4-11, Factoring Tricky Trinomials, a greater than 1. Today's learning target is, I can factor a tricky trinomial by using slide, divide, and bottoms up method. So over the past few weeks, we learned how to factor trinomials when a is 1, but that's not always the case. Today we're going to learn how to do a new method of factoring that allows us to factor trinomials that do not have a GCF and a leading coefficient greater than 1. So then when we talk about a leading coefficient, we talk about the number that's attached to our x squared. So when we are given a polynomial in the form ax squared plus bx plus c, and if a is greater than 1, then we follow this procedure. So here are the steps for tricky trinomial factoring. The reason why we call them tricky is because they have some tricky moves. This example says factor the expression 3x squared plus 7x plus 2. Step 1 says multiply the first term and the last term. So that's exactly what we're going to do. We're going to do 3 times 2. And that's equal to 6. Now, step 2 says rewrite the trinomial without the leading coefficient. So I'm going to drop my 3 and just write x squared plus 7x. But it says replace the constant with the product from step 1. So I'm going to take this 2 and turn it into a 6 because that's what it just turned into. Now we're going to factor this trinomial. So I want to figure out what adds up to 7 and multiplies to 6. So I write out my factors of 6, which are 1 and 6, and 2 and 3. I draw my diamond. My 7 goes up top. My 6 goes downstairs. It's got to be a 1 and a 6. So now I have x plus 1 times x plus 6, because 1 times 6 is... Oh, sorry, I meant to put my... No, that was right. 1 times 6 is 6. 1 plus 6 is 7. So I have x plus 1, x plus 6. One second, let me just look at something. Yep, we put the number we want to multiply to on top. So I'm going to put my 6 here and my 7 here. Sorry, I made a mistake. We do it a little differently in Algebra 2. Now, step 4 says divide the last term in each binomial with the dropped coefficient. So you see how I dropped this 3 before? I'm going to put that 3 back into the equation by doing this. X plus 1 over 3, x plus 6 over 3. Because that's what we're doing. We're dividing the last term in each binomial with the dropped coefficient. Step 5 says reduce the fractions if possible. So if you want to see like a quick check to be like, oh, if I can reduce it, here's what we're going to do. We're going to look at our fractions. So we have 1 divided by 3. We hit math, enter, enter, and we get 1/3. It's already reduced. So I'm going to just leave that as an x plus 1/3. Now I'm going to do 6 divided by 3. And if I look, that reduces to a 2. So this just becomes x plus 2. Now for step 6, it says, for fractions that were made, slide the denominator in front of the first term in each binomial. So what I'm going to do to this 3 is I'm going to bring this 3 up and put it next to my x. So this now becomes 3x plus 1, x plus 2. And this is my final answer. Now if I were to do a box method on that, it would end up being correct. Questions number 1 and 2. Factor each of the following polynomials by using the slide, divide, bottoms up approach to tricky trinomial factoring. So the first thing we do is we multiply our 10 and our 2, which gives us 20. We now want to factor the expression x squared plus 9x plus 20. We want to figure out what adds up to 9 and multiplies to 20. So I list my factors of 20, which are 1 and 20, 2 and 10, and 4 and 5. I fill in my diamond. So my 20 goes up top, my 9 goes downstairs. I have to ask myself, which of those pairs will work? 4 and 5. 4 times 5 is 20, 4 plus 5 is 9. So I really want to factor this. X plus 4 times x plus 5. Now I have to take this 10 and bring it back in. So I'm going to put those terms over 10. So I have x plus 4 over 10 and x plus 5 over 10. I'm using my calculator. So I do 4 divided by 10, I hit enter, and I get 0.4. We don't like that, so I hit math, enter, enter, and this becomes x plus 2 over 5. So I have x plus 2 over 5. What does 5 over 10 turn into? 1/2. So I now have x plus 1/2. And now if you remember, for step 6, it says for the fractions that were made, slide the denominator in front of the first term of each binomial. So this expression will turn into 5x plus 2. And then this expression will turn into 2x plus 1. And that's my final answer. Number 2, we have 3x squared plus 11x minus 4. The first thing I do is I multiply my 3 and my negative 4. 3 times negative 4 is negative 12. So I want to add up to 11 and multiply to negative 12. So I list my factors of 12, which are 1 and 12, 2 and 6, and 3 and 4. Now I draw my diamond. I put my negative 12 up top and my positive 11 downstairs. So I know if I need to multiply to a negative number, I need one positive and one negative. What are the numbers that would work for this diamond? Very good. It would be my 1 and my 12, but it would be negative 1, because negative 1 times 12 is negative 12. Negative 1 plus 12 is 11. So I'm really factoring this expression. I'm really using this expression. X minus 1, x plus 12. So we're really factoring this trinomial. I forgot to write this, but x squared plus 11x minus 12. Where I add up to 11 and multiply to negative 12. So now that I dropped that 3 has to make an appearance. So I'm going to put both of those constants over 3. So if I use my calculator, I'm going to type in 1/3. So I do 1 divided by 3. I get math, enter, enter. So that's going to stay a 1/3. Now I do 12 divided by 3, and that gives me 4. So I'm just going to leave this as x plus 4. Now we do our bottoms up. So this becomes a 3x minus 1. And then I get the x plus 4. And that's my final answer. All right, let's go on to the next one. We have 8x squared minus 18x plus 9. The first thing I do is I do a slide. 8 times 9 is 72. So what I forgot to do in the previous problem, what I'm going to do now is I'm going to rewrite the trinomial that I want to factor. I want to factor this, x squared minus 18x plus 72. I want to figure out two numbers that add up to negative 18 and multiply to 72. I have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and then 7 doesn't go into it, 8 and 9. Perfect. So one of those combinations will give me a negative 18 and multiply to 72. What are they? Very good. 6 and 12. Now, if I look, I have a negative 6 and a negative 12 because negative 6 times negative 12 is 72. Negative 6 minus 12, negative 18. So I really want to factor x minus 6, x minus 12. But I need to bring this 8 back into the equation. So I'm going to put the 6 over 8 and the 12 over 8. Now I use my calculator, and I do 6 divided by 8. I get 0.75, math, enter, enter. And I get x minus 3/4. Now I do the x minus 12 over 8. So 12 divided by 8, math, enter, enter, and I get x minus 3 over 2. Now we do our divide, which we did, and now we do our bottoms up. So the 4 goes up, so I have 4x minus 3. And now the 2 goes up, so now I have 2x minus 3. And that's my final answer. Now you're going to do number 4 all by yourself from start to finish. Type in your final answer. Okay, so for number 4, the first thing we do is we do 7 to 8 gives us 72. So I want to factor x squared minus 26x minus 72. I want to add up to negative 26 and multiply to 72. Well, over here we just did the factors of 72, so I'm going to copy and paste them. So let me just change the color. That way it sort of like separates it from the problems. So I fill in my diamond with a negative 72 and a negative 26. I need to figure out which of those will give me a negative 26. Oh, 7 times 8 isn't 72, it is 56. So 7 times 8 is 56. So I list out all the factors of 56, which are 1 and 56, 2 and 28. Let's see what else. Factors of 56. 1 and 56, 2 and 28, 4 and 14, and 7 and 8. So now what we're going to do is we figure out which of those is going to work. And it's going to be the 2 and the 28. But the 28 is going to be negative. So I have 2 times negative 28 is negative 56. And then 2 plus negative 28 is negative 26. So now I'm really factoring x plus 2, x minus 28. Now I put that 7 back in. So I do my calculations. So I do, let me pull up the notability, that way I can see it. So I have 2 over 7, hit math, enter, enter, and that stays at 2 over 7. So it's going to stay as x plus 2 over 7. And then I do 28 over 7, and that becomes just x minus 4, so nothing changes. Now this 7 goes back up, and it becomes 7x plus 2 times x minus 4. And that's your final answer. So if you have any questions, please let myself or Ms. Townsend know. But now work on your delta math. Have a great day.